Let's name this molecule. We're going to start by identifying the parent chain, and we're spoiled for choice. There are two parts, both that have 6 contiguous carbons, so we know the name is going to have hexane in it, but we still don't know what the parent chain is. We need to look at each path and count the number of branches that come from it. On the left-hand side, this path has 4 branches. On the right-hand side, this path only has 2 branches. The parent chain is going to have the largest number of branches if it has the same number of carbons as another path. So the left-hand side is the structure that represents the parent chain. Now we need to identify the branches or substituents that are attached to the parent chain. We have 2 options here. We can number from the left to the right or from the right to the left. Numbering from the left to the right, we see that the substituents are at positions 3, 4, 5, and 5. But if we number from the right to the left, the substituents are at positions 2, 2, 3, and 4. The appropriate numbering is going to have the lowest number. We're choosing between 3 or 2. The lower is 2, and so we are numbering from the right to the left. Next, we need to name the substituents, name the functional groups. We need to put them in alphabetical order. So to start with, we can see that we have 2-methyl, 2-methyl, 3-ethyl, 4-methyl. Okay, so it isn't by number, it's by the first letter of each functional group name. So what we're really doing here is comparing E with M. E is earlier in the alphabet, so we're going to describe ethyl first of all. But we have 3 different methyl groups. We need to tell people that there are 3 of them. We achieve this by putting tri for 3 in front of methyl. And so the name for this molecule is going to be 3-ethyl 2,2,4-trimethyl hexane. What we learnt here is that if there is a tie for candidates to be parent chain with the same number of carbons, of these options, the parent chain has the more branches.